All right, in this video lecture, we are going to discuss the topic of dilutions. So what a dilution is increasing the amount of solvent while keeping the amount of solute the exact same. When you add solvent and you don't touch the amount of solute, your concentration will be reduced. So for instance, in this beaker, we have our 6 molecules of solute in a very small amount of solvent. If we add more solvent, which in this case is water, we see that it's just the same 6 solute molecules, just now in more solvent, which brings the ratio of solute to solvent down, which means that we're going to have a less concentrated solution, or we can say that it's more dilute. When we're not touching the solute, we are only going to change the amount of solvent. So for instance, right, as a chemistry teacher, I buy lots of chemicals each year, and it is way more cost effective for me to purchase really concentrated solutions. So like hydrochloric acid, I purchase a stock solution that's 12.1 molar, which is way more concentrated than we ever use of hydrochloric acid. So I'm able to just use that stock solution that's super concentrated and dilute it to make the concentrations that we use in the lab, which are anywhere from 0.1 to 1 molar, so very dilute. But it saves money because I can just buy this one bottle of hydrochloric acid and it lasts me for years because I just keep diluting it when I need some, instead of just buying bottles of this in the 0.1 molar concentration or the 1 molar concentration, which would be way more expensive. The calculation to complete a dilution is M1V1 equals M2V2. M1 is the molarity of your starting solution, which we call the stock solution. V1 is the volume of that starting solution that you're using. M2 is the molarity of your desired solution or your final solution. And V2 is the final volume of that desired solution. The thing here is your volumes have to be the same unit, and it doesn't matter what that unit is. It could be liters or milliliters, it doesn't matter. If you want to stay in the habit of converting your volumes to liters, you can do that. But if I give you 2 volumes in milliliters, don't feel like you have to convert them. As long as they are the same, the calculation will come out to what it is, what it needs to be. So for example, you're asked to dilute my 12.1 molar hydrochloric acid solution in order to make 500 milliliters of a 1.5 molar solution. We want to know how much of the stock solution we need, and then how much water we need to add to it to get to our final desired solution. So we're going to utilize the M1V1 equals M2V2 equation. The M1 is the molarity of our starting solution, which is the 12.1 molar. V1 is the volume of that solution that we need, which is what we're trying to find. M2 is the molarity of our desired solution, which in this case is 1.5. And our V2 is the volume of our desired final solution, which is 500 milliliters. So we're trying to solve for V1. If I plug all those numbers in and put x in for V1, we can then solve for x. We can multiply 1.5 times 500, and then we would divide by 12.1, and we will get x to come out to be 62. Now the unit for the volume is based on the unit of the other volume, because your volume units are always going to be the same. So since my V2 unit is in milliliters, my V1 will be in milliliters. So this answer is saying that we would need 62 milliliters of the 12.1 molar hydrochloric acid. And to find how much water we would need to add to it, we want 500 milliliters total. So if 62 are the HCl stock solution, the other, what would that be, 438 milliliters would be distilled water. For example 2, you require a 0.5 molar potassium cyanide solution for an experiment. Your teacher only has 5 milliliters of a 2 molar potassium cyanide stock solution left in her supplies. What volume of the diluted potassium cyanide solution can you make from that? So again, we're going to utilize the M1V1 equals M2V2 equation. Anytime you're looking at two different molarities and getting from one molarity to the other, that's a dilution. So my M1 is the molarity of my stock solution, or my more concentrated solution, so that would be 2 molar. V1 is the volume that I have of that stock solution, which in this case is 5 milliliters. M2 is the molarity of my desired solution, which is 0.5. And I'm solving for V2. I want to know how much of that 0.5 molar potassium cyanide solution I could make based on how much of my stock I have. If I plug those numbers in to their respective variables, I'm plugging x in for V2. I can then solve for x by doing 2 times 5 milliliters divided by 0.5, and I would get x to come out to be 20, and the unit would be milliliters because that's the unit of my V1, and my volume units always have to be the same. The last dilution example problem, you take 12.5 milliliters of 5.80 molar sulfuric acid solution and add 0.500 liters of distilled water to it. What is the concentration of your new solution? By the way, I forgot to add, sig fig rules do apply to dilution calculations. We are going to utilize our multiplication and division rule, which says that our final answer will have the same total sig figs as the starting number with the smallest amount. So if we go back to example 1, we had 3 sig figs in 12.1, 3 sig figs in 500, because there's a decimal here, and 1.5 in 1.5 has 2 sig figs. So 2 is the smallest amount, so our answer should only have 2. In the second example, we had 1 sig fig, 1 sig fig, 1 sig fig, so our answer should have 1. In the case of example number 3, we're going to use the dilution equation again. Our M1 is the molarity of our stock solution, or our more concentrated solution, which is 5.8. V1 is the volume of that stock solution, which is 12.5. M2 is the concentration of the new solution, which is what we're trying to find. And V2 would be the volume of our final solution, which is 0.5 liters. However, our volumes are not the same unit, so we need to convert one of them so that they are the same unit. Doesn't matter which one you convert. I chose to convert the liters into milliliters, so 0.5 liters. Move the decimal 3 spaces to the right would get me 500 milliliters, maintaining the 3 sig figs, so I put a decimal here. You can also convert 12.5 milliliters into liters, which would require you to move the decimal 3 spaces to the left. So if you converted this one to liters, it'd be 0.0125 liters. Once I have the volumes in the same unit, we can plug it into the equation and solve for x, which is m2, and we would get an answer of 0.145 molar to 3 sig figs, because this has 3, 3, and 3, so our answer should also have 3. That is it for dilutions.